Hi, everybody. Thank you for the introduction, Cyril. I'm happy to be here to talk to you about productization on the 3D Experience platform, especially linking CATIA to Solidworks or other software using the 3D Experience platform as a common data environment. My name is Jonathan Asher. I'm a part of the CATIA Global Sales team, in charge of sales for what we call new core industries. Those are industries focused on architecture, engineering, construction, infrastructure, energy, materials, and cities and public services. I'm excited to be with you today. And we're going to talk about CATIA and productization for the construction industry. A quick reminder, the pillars of our CATIA construction portfolio and offer are related to these four main subjects: being smart, being modular, being generative, being continuous. Continuous in terms of project development and level of detail, level of development. These pillars all lend themselves perfectly to the productization approach for construction. And through the use of systems engineering, a systems engineering methodology and approach to construction, creating modular parametric templates that can be reused across projects, instantiating or integrating those modular components with the generative design technology and approach to design, engineering, and construction is a great way to lend itself to then developing the model continuously over the course of the project through all phases. And they all are then deployed in this productization approach for construction. And there's a difference between industrialization in construction, which has its roots more in the manufacturing industries, versus productization. When you look at industrialization in manufacturing, we think of automotive and aerospace, industrial equipment, where supply chain is an essential component to optimizing manufacturing. And when we optimize manufacturing, well, that's great for something like an automobile, where it's a standard assembly of custom components. Every component is fine-tuned and tailor-made to optimize the assembly of that product. Well, a building is the opposite. A building is a custom assembly of standard components, where these standard components are not optimized for the final custom assembly that's going to be delivered for the construction project. So the modern methods or modern approaches to industrialized manufacturing are difficult to apply to an industrialized construction. The two approaches just don't mix so well together, which is why productization as an approach to construction is something that lends itself very well to this custom assembly of standard components, because you can take standard off-the-shelf components, you can integrate them into custom generative assemblies, and then build that final product, which is the finished construction, whether it's a building or an infrastructure project, for using the same technological bricks that you would for this industrialized manufacturing. So that's the key distinction between industrialized manufacturing versus productization in construction. They share many threads, but there are nuances between the two. And by deploying productization in construction is where you can see those efficiency gains that are going to bring construction productivity and efficiencies and margins back up in line with the same types of gains that we've seen in the manufacturing industries since the Industrial Revolution. What is productization then in construction for CATIA? From CATIA, we see it as a multi-layered approach to developing the 3D virtual construction twin. It starts with standardized components, standard components that are digitized. Digitized, they're parametric, so they are flexible and they're able to adapt when a standard component is built up or inserted into a model. From there, you build these parametric assemblies. Parametric assemblies integrate parametric standard components. And those parameters from the standard components are nested or integrated into the parametric assemblies so that you can create another level of intelligence or another level of flexibility, configurability into that component, into that module. Next up, we have generative modular variants. This is when parametric assemblies are layered together and given is a rule-based intelligence within them, rule-based decision-making inside of them, so that they can adapt or they can change or they can modify when they are integrated into the larger model. So the generative module variants, they're generative modules that can express themselves in different ways based on their configuration. Then they're configured into products. So you see, we're building up intelligence, we're layering information. And because all of these components are parametric and generative, they can be configured based on the unique requirements of a project into which they are deployed. So these configured products are essentially expressions of the generative module variants based on the specific project requirements. That's a quick look at productization and construction, what it means for us from CATIA on the 3D Experience platform. You can see here how we can, CATIA is a part of the 3D Experience platform. We are one brand of many. Our sister brand, Solidworks, is widely used in the construction industry to develop products, standard components. Here we see an example of a door or a configurable bathroom pod. These are components and simple, and detailed parametric assemblies that are developed in SolidWorks that can be integrated into CATIA via the 3D Experience platform to create generative module variants and configured products. And these configured products, when inserted into a larger project, create the construction twin, the virtual construction twin. So now let's look at how that looks in reality. This is an example where we'll launch the project with new SolidWorks connected. You can launch the SolidWorks connected to the 3D Experience platform and access all of your SolidWorks models from the platform. You can open them up in SolidWorks desktop. Well, here we're reviewing it in 3D Play to look at the overall assembly. But that model can be opened in SolidWorks, directly in SolidWorks, and where you can make modifications to this standard component. This modification, if you want to change the door panel curve or change the door handle or change some of the design lines or some of the manufacturing information with the notches or the cutouts or grooves, you can do that all in SolidWorks. As we see here, this SolidWorks model is saved to the 3D Experience platform. And because it's saved to the 3D Experience platform, it's available to designers downstream, to CATIA users downstream who want to integrate this standard component into their parametric assemblies or generative modules. Here you see the saving of the SolidWorks model to the 3D Experience platform. It's connected directly to the same common data environment that we're going to be using in CATIA on the next step. So now we're working on a larger project in CATIA. Working on a larger project to develop this new urban development in a particular city. We want to integrate those door modules, those standard components, into our larger project assembly. We've got a couple of examples here where we have the exact model that we just saw modeled in SolidWorks. We've got a couple of other doors that have been modeled in SolidWorks, and we want to create those as reusable parametric templates. Now, if you want a detailed look at how this is done, I invite you all to go to our CATIA AEC or CATIA Construction YouTube channel, youtube.com/CATIA AEC, to watch the step-by-step video tutorial that was released that shows exactly how these SolidWorks parametric components, standard parametric components, can be integrated into your CATIA model through object types, and then instantiated automatically with component-based design. What you see here is we've taken that object type, we have a low level of detail, a pad, a volumetric rectangle representing the low LOD door inside the object type, and then we have, as a second step, the high level of detail SolidWorks model included as an engineering template, which is instantiated automatically when we run the change LOD command. So change LOD is going to take the engineering template and automatically instantiate that engineering template into our model. And I'll skip ahead to see what that looks like, because here we're just going to be we're inserting a couple of low LOD doors, low LOD windows into our 3D model. And now when we launch the change LOD command, it brings up the dialog box. We select which doors or windows we want to instantiate from the object types. In this case, we're selecting all of them. And after CATIA processes all of these engineering templates, you can see them popping up into the model now. We can navigate around and see those different standard components that have been inserted into the model. It's a simple example. It's a very straightforward example. And yet it's a very powerful example to show how these different standard components can be easily inserted into your model. And that's the productization approach. Okay. Now I'm going a bit too slow here. I'm going to speed it up. Here's another example of an assembly, a bathroom pod assembly in SolidWorks. This different bathroom pod has a couple of different configurations. So within SolidWorks, we've configured the bathroom pod in 4 or 5 different ways so that the piping and electrical outlets and all of that changes based on the configuration. The configuration can be a dimensional configuration or a different component integration configuration, different types of configurations, and that's going to lead to different interfaces. The bathroom pod here has interfaces to electrical and interfaces to the hot water, cold water, and drainage. This bathroom pod, again, is configurable, so changing the configurations is going to change the overall 3D assembly, and it's, again, connected to the 3D Experience platform. It's in the platform. That data is available on the web. Here we're navigating the different parameters on our dashboard, and that assembly can be integrated into our CATIA assembly. So here, because we're on a common data environment, that is the 3D Experience platform, the SolidWorks assembly can be searched for from within our CATIA modeling environment, inserted into our 3D model, and positioned as if it were a regular CATIA assembly. That's the exact same model that we had. We can position it inside our larger assembly with a simple drag and drop. We can grab it, we can move it around, we can snap it into place, or we can create engineering connections to make sure that it's parametrically connected to the axis systems that we've defined within the skeleton of our CATIA model. And now what's really incredible is, because we need to connect this model via the interfaces to our CATIA model, we can start to connect these two components, one and the other, with the two assemblies, the SolidWorks assembly with our CATIA assembly. We already have the riser stack in this 3D model. Let's see if we can find it here. This is a riser stack that was modeled in CATIA in the global context of the project. And now we need to link the interfaces, link the riser stack interfaces to the SolidWorks assembly interfaces. The SolidWorks assemblies interfaces, well, those are static because they've come from SolidWorks. And they'll change if we go back into SolidWorks and we change the configuration. Those interface points could change. Our CATIA assembly, our CATIA riser stack assembly, this is a parametric assembly that's going to update live in CATIA. So when we connect the two interfaces between the interface to the SolidWorks assembly and the interface to the CATIA assembly, and we run an update, we should get everything to update. So here we're running the update, and you'll see it was quick, but the CATIA interfaces updated automatically to the SolidWorks interfaces. So it's a way to connect the two types of modules together into one construction twin. And now if we need to move that assembly for whatever reason, because this is parametric, in this case, we're going to move the SolidWorks assembly a little bit. We're going to run an update, and all of those components are going to update for us. Like magic. Let's run an update. And everything's reconnected. So that's an example of taking it to the next level, productizing your model with parametric assemblies. Now let's get into generative module variants. Okay, so this is really exciting because in CATIA, you can do really, really incredible generative modeling. So in this case, we've got a couple of examples of a generative module assembly in CATIA. This one has been developed to incorporate framing of a wall. So we've got structural wood framing that's happening, and it adapts, and it's parametric, and it's generative in the sense that as you add doors, as you add windows, as you add different features or different components inside this this wall, all of the framing is going to automatically update. It's rule-based, so the framing conventions and framing rules have been integrated into this component so that it's easy so that you know whenever you add a component to this wall, you're going to get code compliant framing updating within your model. And it's parametric, so if you need to change any of those parameters based on the location or the country within which you're placing, or you're going to be using or deploying this wall, that's all integrated. Here's another example of a highly detailed rebar assembly that's being built based on a volumetric input. So the input to this generative module assembly is a volume, and any adjacent volumes that need to be taken into account for rebar coordination between, say, the slab above, the slab below, adjacent walls. And what it's going to do with this generative module assembly is create all of the very detailed rebar that needs to be manufactured for this wall, the blockouts for the openings, any special fittings that need to go into, create the manufacturing information, and the drawings. The drawings that include the layout drawings, the assembly drawings, the site drawings, all of that comes with this template, which is incredible to have that integrated into one place. And now, new in 24x CATIA 3 experience on the cloud, we have a Revit Power By option. So in this case, I'm a general contractor. I'm receiving models from my architect. My architect is giving me Revit models, but they're connected to the 3D Experience platform. They're connected to my 3D Experience platform. So they're saving their Revit model to 3D Experience, and I'm going to open that Revit model in CATIA without conversion, without any issues. I can open that model and directly consume the geometry from Revit to bring it to the next level of detail. Now, in this case, I have a wall that I need to pour as concrete. In order to generate that concrete wall, I'm going to instantiate that generative module assembly, that rebar template that we just saw in the previous video. It's very easy and straightforward. I select the wall volume from Revit, I instantiate my template, I run an update, and I get all of the geometry, all of the drawings, all of the manufacturing from that template updated for this model. Now let's say there's a design change that needs to happen. We need to change the opening size for this wall. I make a request via the platform to my architect to change the size of the window, create an issue, he or she receives a notification. Back in Revit, the change is made. Back in CATIA, once that change has been made and saved to the platform, I update my model and everything automatically updates. The rebar updates, the drawings update, everything. So no rework. There's a direct parametric link between the Revit model that's saved to the platform and the CATIA model that's automatically generating all my construction details. It's a fantastic and exceptionally powerful workflow that will absolutely be a game changer in the industry. Finally, now that's the CATIA option. The last video I want to talk to you about in productization are these configured products, because when you bring this all together, you can make some beautifully detailed and highly parametric, highly generative models that are project specific and put together based on project requirements. So again, I mentioned at the very beginning that we have all of these really wonderful functionality that have been developed for structures, for systems, for architectural design. Here's an example where you see that all coming together. This is the civil structures design application where we're placing columns and beams and slabs and plates. All of that very simple and simple to use out of the box. Now we're going to go into the building 3D design application, add some walls, add some doors, add some windows, add those architectural elements, simple, easy. We're also going to insert our generative module assemblies. So here we've got a couple of templates that do the wood framing, as I mentioned earlier. We've got another one for partition walls to insert partition walls. I'm going to skip forward a little bit. You've seen the automation magic happen already, so you don't need to see it again. There's our wall. What do our walls contain? They contain the drawing information that you need with the different components. So you've got the insulation, you've got the panel layout, you've got the framing layout. All of that comes along when you insert that template, and it adapts to the local condition. It adapts to the configuration required for the assembly. You can insert components for the ventilation system, for the HVAC system, you saw the riser in a previous example. All of that, once you've done it once, that's reusable across all projects, any projects. And so we're going to add in the ventilation system to this module. Let's say you need to add some doors. You saw doors in another video. Here we're going to grab a door, we're going to place it in the door, and you're going to see that with the magic of these parametric module assemblies, you run an update, and all of these framing, all of the framing requirements are going to update, all of the framing information, geometry, drawings, all of that updates because it's been integrated into the creation of this parametric module assembly. And again, we've got the dimensions, we've got the annotations. This is the 3D master approach where the 3D model is the documentation for construction. Yes, you get the drawings. Yes, you get the manufacturing data to run all of your digital manufacturing equipment and in your shop and your facilities. But the 3D model also is there as a check. All the dimensions are there so that you can check it and validate that everything works. And it's parametric. So when you make the change, you change the dimension of this unit, you change the size, because you're going to deploy it in a different project, or you're going to deploy it as in one dimensional configuration in one area of the building and another dimensional configuration in a different area of the building. You change the dimensions, you run an update, and everything's going to reconfigure itself because you've instantiated, you've integrated these generative module assemblies to create your configured products for this specific project. So that's an overview, a rough overview of productization in construction. Using CATIA, SolidWorks, Revit on the 3D Experience platform. The 3D Experience platform being that common data environment that brings everything together. Project management, the 3D modeling, building information modeling, product lifecycle management, building lifecycle management. It's all integrated here into one place where a project can be developed from an architectural design standpoint, pass through all of those phases of design, development, construction documentation, and go straight into the productization for construction phase, where these configurable products that integrate all of the different layers of componentry that we saw are integrated into the modules to build that virtual construction twin. With that, I appreciate your time. I hope this was an informative session. Don't forget to join us on our community, our building and civil community, buildings and infrastructure community, to connect with experts, ask any questions, and I look forward to speaking with you in the future. Thank you very much. Have a good day. Bye.